So again, thank you, Filippo, for inviting me and of course for coordinating all of this. So as we already discussed, yes, I will talk a little bit about me and about the theoretical background, design and funding of this paper, applying bodily sensation map for Art-Elicited emotion explorative study. Then we will have the 5 minutes break and we will follow the discussion will follow with some Q&A. Okay, so as I was saying, I'm from Italy. I got my bachelor degree in psychology and then my master degree in talent development and creativity, and started my PhD as a follow-up from it. Our research team is called Measuring the Experience and Meaning of Art. And it focuses on the empirical investigation of artistic experiences, which by that, I mean art production and art appreciation and the meaning of art. The paper I'm gonna present is is the first project of my PhD, and yes, let me give you a bit of a theoretical background about this. Okay, so when we talk about emotions, we talk about a unified experience of the mind and the body. Emotions are then often felt in the body, and somatosensory feedback has been proposed to trigger conscious emotional experiences. So in order for an emotional experience to occur, the bodily sensation must be noticed, and in that way, we can categorize them into appropriate subjective feelings. For example, I feel happy, I feel sad, I feel anger. In this view, emotions are emergent and dynamic kind of phenomenon, and it can occur in response to a situation either real or imagined. Following this, emotional responses to art should make no exception. There are different methods used to measure emotions. Emotions in psychology can be measured through, for example, affective computing of physical information, or through the use of interviews, checklists, questionnaires, all with verbal components, or through visual self-report tools. So visual self-report tools are indeed these pictorial tools, and that can report the affective state in a very quick, intuitive, and accurate way. And most of the time without the language complication, because indeed they do not rely on the verbal component. So they can be especially helpful in emotional events where the verbal recollection can be challenging. So the study we conducted investigated the emotional evaluation of artworks based on the self-report technique of bodily topography, which is called bodily sensation maps, or BSM for short. Numan and my colleagues developed a software in 2014 called Embody. This software enabled participants to paint their sensation onto empty bodily silhouettes, and in turn, it allowed us to have this topographical visualization in the form of heat maps. So it has been found that different emotions are indeed consistently associated with statistically separable bodily sensation maps across different kind of experiment with different kind of stimuli. They have been used emotion words, movies, stories as kind of stimuli. The tool has also been validated in different contexts as well, in different populations. It has been validated with social scenarios, with depressed and schizophrenic individuals, and so on. In our paper, we generalized its use to measure the emotional responses to visual art. So the main idea of BSM is indeed that people can report to two types of activity in their body. Activation, which are displayed with these red dots, the red shades that you saw before, yes. And those report where people felt like the activity in their body getting stronger, such as heart pounding, flash in the face, muscle tensing, and so on. And then they're also asked to report the deactivation felt in their body. And that will mean where the people felt activity getting weaker. So the shades that you see in blue. And that will correspond to your feelings of feeling lightheaded or numb or some woozy body part. So keeping all of these concepts in mind, and that we did not assume a special phenomenological experience during art encounters. That means that we did not assume that the traditional aesthetic experience of beauty and pleasant emotion is the only possible way of experiencing visual artwork. Then we aim at answering these following research questions. So first of all, we wanted to know whether people will actually report bodily sensation while looking at visual artworks. Then see what kind of subjective feelings were elicited throughout the experiment. And lastly, how bodily sensations and subjective feelings relate in emotion provoked by artworks. So to this end, we designed the experiment described in our paper, which you can also access by just scanning the QR code. If you want to have a better look at it, just feel free, of course, to read it. But of course, for now, you can also just lay back and relax, and I will go into it right now. So we collected data from 90 psychology students. They answered a web survey built in Qualtrics. Qualtrics is a web software for online surveys, indeed. It's a very user-friendly software with which you can build an experiment. Participants had to answer a few demographic questions, so gender, age, and whether they were native English speakers or not. And then they observed 36 new media visual artworks and answered some questions about their emotional experience towards them. So let's have a look how each of the stimuli look like. And here is a very big overview about it. As explained, participants were presented with new media visual artworks. So new media, by the definition given by Quaranta, new media art is the art produced with means like digital means. So what we did by picking new media visual art, we picked digital paintings because they were meant to be for a screen-based experience. And thus they were not a picture of a real life painting. They were not a reproduction of a traditional paintings. We choose figurative artworks. As you can see, they're not abstract, they really represent something, right? So we chose figurative artworks for our experiment since the aim of the paper was to provide artworks that could elicit different kind of emotions. And figurative paintings, especially for lay people, allow to have a better insight on what emotion they conceive. And in this way, also for us as researchers, we could establish a preconceived notion of the general emotion that artworks was going to convey. So we reached out to 6 artists with different artistic styles, such as realism, impressionism, comics, surrealism, cartoons, and manga. And we asked to each of them permission of use for 6 of their digital paintings in this experiment. At the end, we had this final selection of 36 artworks that you see in the slide. As you can see, the emotional content ranged from neutral scenes, such as the one of the TV in the living room, but also sad, happy, or even disgusting ones. Moreover, the figurative contents are also quite various too. So there are objects, landscape, human figures, and monsters. So each digital painting was displayed for 15 seconds, and then participants were asked to point out in their body where they felt the activity getting stronger, thus the activation, and then where they felt the activity getting weaker, so the deactivations. And lastly, to label and categorize the bodily sensation. They could drag 1 or 2 sliders to better identify the emotion they felt and also the intensity they felt that emotion. For this reason, we provide them with 6 emotions, which in psychology have been identified as being the basic universal emotion according to Ekman's theory of emotion. Of course, the possibility of a neutral state was taken into account. So if participants will not feel anything special, they were asked to not select any slider, and that would have been interpreted as neutral on our behalf. Alternatively, as we said, they can also select 2 sliders. that will result in a complex emotion. Or to be more accurate, yes, we will interpret it in light of the Plutchik's model of complex emotion afterwards, so doing our analysis. We decided to analyze the complex emotion that occurred the most, which are despair, delight, bittersweetness, and repugnance. So let me just explain a little bit what does this mean. This means that, for example, in this example, if a participant selected anger and sadness, then we as researchers afterwards would interpret that as envy, for example. And as I said, we analyzed and took into account in our analysis just the one that occurred the most, because in that way we had more data about it. So we analyzed despair, which is a combination of sadness and fear, bittersweetness, a combination of sadness and happiness, delight, a composition of surprise and happiness, and repugnance, which is a combination of disgust and fear. Just one note here, because Plutchik called this combination, the last one of disgust and fear, he called that shame. But we embraced Tenhoute's adaptation because it seemed more relevant and appropriate in this context, and it definitely brings less cultural implication with it. So, although this may look like a simplistic view on the very complex topic of emotion, it was a methodological choice in order to start approaching this complicated matter. So, when we got all the data, we got something that looked basically like that. So I want to give you this sneak peek of our data set while we were polishing it. In this screen, we have 30 responses to stimulus 1. Each participant corresponds to a row. And as you can see, each column reports respectively X and Y coordinates of the points selected by the participants, for a maximum of 10 points for the activation and 10 points for the deactivations. At the end of the screen, you can see also the values for each of the sliders. So if we filter the data by emotion, we can then have a look at the emotion-specific DSM for that stimulus. In this example, we select sadness, right? And we get the activation, deactivation points selected by participants that felt sadness towards the artwork. In this case, it was stimulus 1. If we will have left a free choice method for participants to express the emotion, then we will have just far too many categories, and the data would have been very dispersive. Since this was mainly a validation study, we decided to keep it simple. Okay, so now that we have our points categorized by stimulus and emotion, we can also divide the coordinates into bodily regions. To do that, we created COUNTIPS formulas in Excel, and they were based on the picture of the bodily silhouettes that we used in the in Qualtrics in the experiment builder. So we collected the counts from the coordinates given by Qualtrics, divided them by these 5 regions of interest, which are the ones selected by November and colleagues, namely head, chest, abdomen, lower limbs, and upper limbs. And then we use them to create the classical heat map as I showed you at the beginning, and that was with the power map function that you can find in the Excel version for Windows though, so it's not available on Macintosh. With this data, we conducted different analyses. We analyzed the frequencies obtained of bodily sensation in terms of location in the body and the occurrences of subjective feelings, either basic or complex. We used chi-square tests as formal statistical analysis. And we found that, first of all, there is an association between activation and stimuli and deactivation and stimuli. And second of all, that subjective feelings share a significant relation with both activation and deactivations of body parts. Then we also analyzed the intensity collected through the sliders with some exploration techniques and exploration of the histograms, to be more specific. Then we also use non-parametric Wilcoxon tests in order to test each frequency reported in body parts per emotion against the neutral state. So how each emotion differs from the neutral state. But I will not go into all of this. I will, as I said, try to give an overview of the most interesting results. So we use contingency tables to explore our data and to run the chi-square test. And we can already spot with this cross-tab some very interesting facts. For example, that activation arises mainly on the head and often on the chest, whereas deactivation is more likely to occur in the lower limbs and upper limbs. Although the cross-tabs already gave us a very nice view of the results and make the results a lot easier to understand, I think the visualization will help even more. So these are the bodily sensation maps, emotion-specific bodily sensation maps that we generated with our study. So as you can see, the light is the one with more points, because the light was the most frequent emotion in our study, that was selected actually 384 times by the participants, whereas the least chosen one was anger, with only 55 times throughout the entire experiment. The results show that each art-elicited emotion are characterized by unique patterns even within the same region. So for instance, although both sadness and happiness share the activation of the level of the head, thanks to the visualization, we can see that the patterns are different. So that sadness has distinctive activation patterns around the eyes, while happiness have an activation on the mouth. And conceivably, one might parallel this finding to the tears shed during the sad feeling or the smile while experiencing happiness. Upon a visual inspection, we also compared our BSM with the one from previous studies. And we found that our BSM were very similar to the one found by Numanma and colleagues about emotional stories. So they found that BSMs resulting from reading emotional stories reported an activation of the level of the head in each of the basic emotion and even the neutral state, which is very similar to what we found, because we can see there is this common thread of head activation also in the neutral state. Therefore, it has been inferred that the guided mental imagery based on reading short story could be the source of reporting the head increased activity. And since this is also in accordance with our finding as well concerning visual artworks, we could suggest that visual art as well as narrative potentially generates some level of cognitive associative activation, which is represented by the increased activity at the level of the head in every BSM. To assess whether the prominent activation in the head and the chest were not primed by the use of human faces and body, we run also control analysis of frequencies. And it revealed that activation in the head and the chest were not typical of stimuli producing human depicting human faces on body parts, because they can be similarly found in responses to stimuli containing food, landscape, or monsters. Nonetheless, stimuli depicting humans, especially half-length portraits, seem to elicit more distinguishable bodily activation in the upper part of the body, and better discern the activation in the lower limbs. This could possibly suggest a mirroring of the embodied simulations. Still, we cannot be definitive about the real reason of this common activation at the level of the head, especially, because it could have different explanation. It could be, again, for the mirroring of the content of the artwork. So we see a face and we report the activation in the face head. It could be because of the use of neural system triggering in bodily simulation. It could be because of the mental effort that we put to elicit emotional imagery. Or it could reflect also the use of just a hedonic system while appreciating art. So We found, all in all, comparable results as previous literature and extended the use of BSM to new media visual artwork. Future direction could implement a stimuli validation step to do beforehand, before the experiments, in order to have more balanced data and to have more control over the data. All in all, we confirmed that specific topographical distribution of bodily sensation can indeed be tested in emotional categories, and that this study corroborates the idea that BSM are an accurate description of subjective emotion-related bodily sensations. So thank you all for listening, and looking forward to the discussion.